Welcome back to this video series on the topic of formidable factorization, Chapter G, Algebraic Long Division. In this lesson, you'll learn how to apply the long division algorithm to simplify algebraic expressions. The long division algorithm may be applied to algebraic expressions. It may be used to simplify algebraic fractions as well as factorize algebraic expressions. Let's have a look at how this can be done by example. We have example 1, simplify the following expressions. We are presented with the expression x cubed plus 5x squared plus 9x plus 9, and this is all over x plus 3. What we would like to do is we would like to simplify this algebraic fraction here using algebraic long division. Now this is going to be done in a number of steps. The first thing we need to do is we need to set up the long division. To do this, I identify the denominator, which is x plus 3, and I write it down as if it is now our divisor. So our divisor is x plus 3. Next, I set up the long division, and inside the long division I write the numerator. This is x cubed plus 5x squared plus 9x plus 9. This is going to act as our dividend, after which I rule this off and I'm ready to apply the algorithm. Okay, applying the algorithm, we call this division, but actually what it is multiplication and subtraction. Now the way in which this works is we're going to have a working expression and we're going to have a dividing expression. Basically, we try to make our dividing expression match our working expression. Our working expression to begin with is going to be x cubed plus 5x squared. And what the goal is we want to make this expression over here match up with this expression. Now the way in which we do this is we modify this expression here. So we look at x to begin with here, and we look at x cubed here, and we say, how can we make x over here match x cubed? And the way in which you do that is you multiply it by x squared. And because we're doing x squared, we identified the square term over here and we write x squared. Next, we're going to do multiplication. We have x squared up here and we multiply x squared with x, and that will give us x cubed. Next, we have a 3 over here and we have an x squared up here. We're multiplying them together. 3 times x squared will give us 3x squared. There's our multiplication. Next, we need to do subtraction. To do this, I'm going to put brackets around what I just put in and turn it into a subtraction. I look at what I have and I say x cubed take away x cubed is 0x cubed plus 5x squared take away 3x squared is the same as writing 2x squared, and our subtraction is now over. We're now going to build our working expression. I've got 2x squared over here, and because I've got these two here, I need this one and I need something here. So I look above and I grab the 9x. I bring it down. So now I'm working with 2x squared plus 9x. I then try and match the divisor over here with my working expression here. So I need to make x look like 2x squared. The way in which I do this is I multiply x by 2, and then I multiply it by x. So 2x times x is 2x squared. Doing this multiplication, 2x squared, then 2x multiplied by 3 will give me 6x. I set up for subtraction, and now I apply the subtraction. 2x squared take away 2x squared is 0x squared, plus 9x take away 6x will give me 3x. Done. Subtraction over. Now it's time to build the working expression again. I need one term and I need two terms, so I look above and I pull this 9 down. Next, I'm going to make the divisor match my working expression. To do this, I've got 3x and I want to turn this into 3x. To do that, I multiply it by 3. Now I'm going to get 3 times x is 3x, and 3 times 3 is 9. Setting up for the subtraction, I'm going to get 3x take 3x is 0x, and 9 take 9 is 0. And lo and behold, we are now at a point where we've got zeros here and no more to do division on. So what we've done is we've successfully completed the long division algorithm on some algebraic statements. Now, finishing this off, what we see is that we had x cubed plus 5x squared plus 9x plus 9 all over x plus 3. This guy over here was our divisor. This guy in here was our dividend. And what we discovered was, up top here we had our quotient, or in other words, our result of the division. So we can conclude that x cubed plus 5x squared plus 9x plus 9 all over x plus 3 is equivalent to saying x squared plus 2x plus 3. And we accomplish this using algebraic long division. So the algorithm is quite long. It's got a number of steps, and as a result, that's why it can be a little bit tricky to apply, because you may be confused. However, with a little bit of practice, then you'll become familiar with all the steps that you need to do, and you'll be successfully able to apply this. Okay, let's have a look at a slightly different case. We have B, 2x cubed minus 3x squared minus 22x plus 8 all over x minus 4. This one is slightly different because we're dealing with negatives now. However, what we're going to discover is that the algorithm is going to remain the same. We start off by identifying our denominator, which will behave as our divisor. Next, I'm going to set up for long division. The numerator in this case is 2x cubed minus 3x squared minus 22x plus 8. And this is going to behave as our dividend. Now, it's time to do the division, where division of course is just a matter of multiplication and subtraction. We turn our attention to our working expression over here, which is 2x cubed minus 3x squared, and we ask ourselves, how can we turn x over here into 2x cubed? Now the way in which we do this is we multiply it by 2, and we're going to also multiply it by x squared. Doing the multiplication, x becomes 2x cubed. Next, 2x squared multiplied by minus 4. Well, firstly, it's going to become a negative. And secondly, 4 by 2 is 8. And then we just attach the x squared. And there's our first bit of multiplication done. We're now going to do subtraction. And this is where it's slightly different. In the previous example, we only had to deal with positives. Now we're dealing with the subtraction of negatives, like over here. First term will be fine. 2x cubed minus 2x cubed is 0x cubed. However, minus 3x squared minus negative 8x squared is a double negative. So what this in turn turns into is minus 3x squared plus 8x squared. So that will become plus 5x squared. If you're a little bit unsure about this still, you just see double negative, so that's positive. And then just go 8, take 3, that's 5. Okay, subtraction's all out of the way. Let's build our working expression. So minus 22x comes downstairs. After which we say, how do we turn x into 5? X squared. We have to go plus 5x. Doing the multiplication now, 5x times x is 5x squared, and then 5x times minus 4 is going to be minus 20x. Going for subtraction, this will give us 0x squared, and then we've got the double negative situation again. So minus 22 plus 20 will give us minus 2, and subtraction is now done. We build our expression by bringing down the plus 8, and now we try and match it. We have x and we have a minus 2x here. How do we turn x into minus 2x? Well, we multiply it by minus 2. Completing this, we go x times minus 2 is minus 2x. And then minus 2 times minus 4 is going to be plus 8. We go for subtraction now. And notice that both the expressions match up. So we're easily going to see that we get 0x plus 0. Thus showing that we completed the factorization, or we completed the long division properly. Finishing this off, we can therefore conclude that 2x cubed minus 3x squared minus 22x plus 8 all over x minus 4 is the same as writing 2x squared plus 5x take 2. Therefore, we are done here. So the things to look out for in these sort of questions is, if you've got the negatives here, be mindful that you might get double negative. So you're dealing with multiplication by negatives or subtraction negatives. Alright, let's have a look at final sort of question that you get in this course. Example 2, we are show that. Rather than simplify, we're doing show. So what this looks like is you have an expression on the left and you have to show that the expression on the left looks like the expression on the right. Okay, putting this together, we have 18x cubed plus 27x squared plus x take 6 all over 3x plus 2. What we're going to do is we're going to apply the long division algorithm to show that this fraction on the left here can be simplified down into the expression shown on the right here. So putting this together, our divisor is going to be 3x plus 2. Our dividend is going to be 18x cubed plus 27x squared plus x minus 6. Alright, applying the long division algorithm, we first look at our working expression, which is 18x cubed plus 27x squared, and we say, how can we make 3x look like 18x cubed? The way in which we do this is we're going to multiply 3 by 6 and then the x by x squared. This will give us 18x cubed plus 12x squared. Going for subtraction, we're going to get 0x cubed plus 27 take 12 is going to be 15x squared. Done. Build the expression by bringing down the plus x. Now try and match 15x squared with 3x. To turn 3x into 15x squared, we have to multiply by 5 and multiply by an x. 5x times 2 is going to give us 10x. We now go for subtraction. This will give us 0x squared, and then x take 10x will give us a negative 9x. We now bring down that minus 6. We ask ourselves, how can we turn 3x into minus 9x? The way in which this is done is we multiply it by minus 3. Doing this, we get minus 9x minus 6. We go for subtraction. Now, it looks a little bit nasty, but one way to look at it is because both of these expressions match, the results have to be 0. And thus we're able to see that the division worked. Now putting this together, we can see that 18x cubed plus 27x squared plus x take 6 all over 3x plus 2 is equivalent to 6x squared plus 5x take 3. And thus we have shown that this is possible. So in summary, what we had a look at in this lesson was how we can apply the algebraic long division algorithm to algebraic expressions. This resulted in us being able to divide expressions by other expressions, simplify algebraic fractions, as well as show that an algebraic fraction is equivalent to an algebraic expression. Now, as I mentioned, this algorithm is quite complicated in that it has many steps. However, with practice, you will remember each and every step and you'll be able to confidently and reliably apply this algorithm every single time.